Good morning, my dear students. In the previous classes, we have completed one lesson. Now today we are going to learn one new topic, that is types of chemical changes. Types of chemical changes. It is a fourth lesson in volume 1. What is called types of chemical changes. Chemical changes. Okay. Already you learned about elements and compounds. Elements and compounds. Okay. And also the symbols of elements and the formula of compounds you learned. Now you should learn here in this lesson chemical equation. Chemical equation. What is meant by chemical equation? What is meant by chemical equation? Chemical equation is a statement that describes the chemical changes in terms of symbols and formula. Okay, types of chemical changes. Okay, this is the lesson we have. This is the fourth lesson in volume 1. So we can learn second and third after this lesson. What is this chemical equation? Chemical equation is a statement that describes the chemical changes in terms of symbols and formula. In this lesson, in this concept, you should learn two terms like reactants and products. Reactants and products. These terms we have to learn. What is meant by reactants and products? What is meant by reactants and products? What is meant by reactants? The substances which take part in a chemical equation, chemical chain, is called reactants. What is called reactants? The substances which take part in a chemical chain or chemical equation is called reactant. The reactants are always written on the left side of the equation. What is meant by products? The substance is formed as a result of chemical chain. Is called products. And products are always written on the right side of the equation. So we should learn about reactants and products. Okay, chemical equation is a statement that describes the chemical changes in terms of symbols and formula. For example, H2 plus O2. Okay. Okay. Now write about reactants. Reactants the substance or substances which take part in a chemical reaction are called reactants. Okay, what is meant by reactants? The substance or substances which take part in a chemical reaction are called reactants. And reactants are always written on the left Okay, reactants are always written on the left side of the equation. Okay, the substance or substances which take part in a chemical reaction are called reactants. Reactants are always written on the left side of the equation. And next one, products. Okay. The substance is formed as a result of chemical reaction is called a product. Okay, the substance is formed as a result of chemical reaction is called product, which is on right side of chemical reaction. So reactants, the substance or substances which take part is a chemical reaction are called reactants, and reactants are always written on the left side of the equation. And products, the substance is formed as a result of chemical reaction is called product, which is right side of the chemical equation. Okay, right on. Okay, next. Some examples, write down. Examples. Okay. Mg plus 2 HCl gives rise to it is called gives rise to Mg Cl2 plus H2. It is balanced. It is already balanced equation. Mg plus 2HCl gives rise to Mg Cl2 plus H2. These are reactants. These are called reactants. Mg plus 2HCl are called reactants. What is called reactants? Which substance or substances which take part in a chemical reaction, that is called reactants. These are products. These are called products. This is one example. Next example. Okay. Here are some more examples. CO3 gives rise to CuO plus CO2. CuCO3 gives rise to CuO plus CO2. Copper chloride. CuCO3 plus CO. Cuprous oxide plus carbon dioxide. These are reactants. And products. These are products. And I want to write some more examples. Mg plus 2HCl gives rise to MgCl2 plus H2O, and CuCO3 gives rise to CuO plus CO2 and reactants. And third one, you can write third one also. And Zn plus O2 gives rise to ZnO, zinc oxide. ZnO, zinc oxide. This is 2. Now it is balanced. 2 Zn plus O2 gives rise to ZnO, zinc oxide. These are reactants and products. And fourth one, ZnCO3, zinc carbonate. ZnCO3 gives rise to ZnO plus CO2. ZnO plus CO2. Zn, zinc carbonate gives rise to ZnO, zinc oxide plus carbon dioxide. These are reactants and products. Okay. Mg plus 2HCl gives rise to MgCl2 plus H2. CuCO3 gives rise to CuO plus CO2. 2 Zn plus O2 gives rise to ZnO. ZnCO3 ZnO plus CO2. So, which are in left side of the equation are called reactants, which are in right side of the equation are called products. And I am writing some more. Like right now after this fifth one, Al plus 3H2O gives rise to Al2O3, aluminum oxide, aluminum trioxide, and 3H2. And sixth one, CuSO4. K2 Cr2O7 plus potassium chlorate 8 H2SO4 gives rise to 2K2SO4 potassium sulfate plus 2Cr2 SO4 price plus H2O plus 3O2 K2Cr2O7 plus 8H2SO4 gives rise to 2K2SO4 plus 2Cr2SO4 price plus H2O plus CO2. Okay, these are some examples of chemical equations and chemical changes. So these are reactants. I want to write like this: reactants gives rise to products. Okay, right now. Now some important characters of chemical reactions, chemical changes. Some important characters of chemical changes, that is first one is evolution of gas and formation of precipitate and change in color, change in temperature and change in state. And some important characters of chemical changes. Okay, the first one is evolution of gas and formation of precipitate means residue, the remaining one, precipitate. Next, change in color, change in temperature, and change in state. Okay, these are the main important characters of the chemical changes. What is the first one? Evolution of gas. Evolution of gas. Formation of precipitate. Precipitate means residue. Residue. Formation of precipitate means residue. The remaining one, for example, take a one reaction. Okay, we have a idea some about the apparatus of chemical equations like test tube. Test tube. This is a test tube. Test tube. Okay. So when the undergoing chemical reactions, when you are taking any chemical reactions in a test tube, after taking the chemical substances in a reaction, so after the reaction, after some time, some changes is taking place in a test tube. Like this is some residue is taking place at the bottom of the test tube. At the bottom of the test tube, some residue or the remaining part is settled down at the bottom of the test tube. That is called precipitate or residue. Precipitate. Precipitate. In residue. Okay, this is called precipitate. This is solution. This is called solution. This is called solution. This is precipitate. Solution and precipitate are divided in two parts. This two parts. One of the part which is high quantity or high weight, that is settled down at the bottom of the test tube. That is called precipitate or residue. Okay, this is precipitate. What is the remaining portion? It is not useful. Okay, that is called change in color. In some reactions or chemical reactions, some changes, some colors of the chemicals. For example, these are reactants, these are products. So after the chemical reactions, the color, in reactants some color is there. After the reactions, you can see some more color, another color in products. Okay, for example, when you take out the reactants, color is yellow. After the reaction, it becomes green. Some green or muddy or green, dirty green or dirty muddy or red color, whatever it is. According to the chemical reaction. So the reactants are changed another color. The reactants are changed into another color as a product after the chemical reaction. Okay, now change in color and change in temperature also. So after the reaction, so we can check the temperature. Whether it is temperature in high or temperature in low. So the products may be in low temperature or high temperature compared to the reactants. And change in state. Change in state means liquid to solid. Liquid to liquid. When you are taking the liquid, maybe it becomes turned as solid state. Okay, when you take gas, it turns into solid or liquid. After taking the solid, maybe it turns as liquid. Okay, the change in state is also occurring during the chemical changes. Chemical changes. What are the important characters of the chemical changes? Evolution of gas. Evolution of gas. So, in some chemical changes or chemical reactions, you can see the formation of evolution of gas or formation of gases is, we can see like oxygen, CO2, H2S. We can see some formation of gases are occurring during the chemical changes. That is called evolution of gases. Evolution of gas, formation of precipitate or residue, change in color, change in temperature, change in shape. So these are the important characters of the chemical changes. Now, evolution of gas. Example of evolution of gas. Example of evolution of gas. Okay. Okay. 2NaNO3 gives rise to sodium nitrate. Sodium nitrate and gives rise to 2NaNO2, sodium nitrite, plus O2, oxygen, Okay. Examples of evolution of gas. 2NO2 in the reaction. So, sodium nitrate crystals are heat. Sodium nitrate crystals, when the sodium nitrate crystals are heated, they form sodium nitrite. This is nitrate, but it is nitrite. Plus oxygen is evolved. After that, so by doing heating, sodium nitrates are heated, the sodium nitrate crystals are heated to form sodium nitrate and evolution of gases occur. So oxygen gas is evolved in the reaction. And second one, can take second one. CuS plus 2HCl gives rise to CuCl2 plus H2S. This is also gas. Okay. CuS. Okay. When the CuS, copper sulfate reacted with HCl, form copper chloride and hydrogen sulfide. Hydrogen sulfide is evolved. 2NaNO3 gives rise to 2NaNO2 plus oxygen. CuS plus 2HCl gives rise to CuCl2 plus HCl. Hydrogen sulfide. This is when copper sulfide react with hydrochloric acid, form a copper chloride and H2S. This is hydrogen sulfide gas is evolved during the chemical reaction. And another one. Okay, these are the examples of formation of example of evolution of gas. Right. Now example of color change. Now example of color change. Okay. CuCO3 copper carbonate gives rise to CuO plus CO2. This is gas. Okay. The copper carbonate color is green. What is green? After heating CuCO3, by the heating of CuCO3 form copper oxide and CO2 gas. This is black. This is black in color. What is the color of the CO copper oxide color? Black. But CuCO3 copper carbonate color green. Copper carbonate. What is the color of copper carbonate? Green. So this is copper oxide black. The green turns as black by the chemical reaction. This is the example of color change. CuCO3 gives rise to CuO plus CO2. This is green in color. Copper carbonate. After the reaction, so these are reactants. These are products. Okay, reactants and products. CuCO3 copper carbonate green, CuO plus CO2 copper oxide black products. Okay, these are example of color change. Now, example of formation of precipitate. Example of formation of precipitate. Okay. Next, FeSO4 solution. FeSO4 plus NaOH gives rise to Na2SO4 sodium sulfate plus FeOH twice. FeSO4 solution ferrous sulfate Okay, what is the color of ferrous sulfate? Light green solution. Plus sodium hydroxide, we know that, and here sodium sulfate, sodium sulfate, FeOH twice, ferrous hydroxide, ferrous hydroxide. This is precipitate, so we have to arrow out like this, below arrow. So we have to like arrow out. For the gas here, for the precipitate it will like this. Dirty green precipitate. Okay. This is the example of formation of precipitate. FeSO4, ferrous sulfate, light green solution. FeSO4 react with NaOH gives rise to Na2SO4, sodium sulfate plus FeOH twice, FeOH twice, ferrous hydroxide, ferrous hydroxide. FeSO4 plus NaOH gives rise to Na2SO4, sodium sulfate, Na2SO4, sodium sulfate, FeOH twice, ferrous hydroxide, ferrous hydroxide. This is the example of formation of precipitate. So, this precipitate like this is precipitate, this is solution, this is precipitate, okay. FeSO plus NaOH gives rise to Na2SO4 plus FeOH twice. This is the example of formation. Okay students, today class up to here. Okay, some more concepts learned by tomorrow. Okay.